All right, so I'm sure you guys are thrilled, but we have more theorems and postulates to write down today. Just two, and then we're going to practice with those. So the first one we're going to talk about is the segment addition postulate. So this says if B lies between A and C on segment AC, right? So that means if B is on the same line and somewhere in between these points, right? Then the length of AB, so the length of this plus the length of BC is equal to the length of AC, right? So basically what this is saying is that when you have a segment, the two parts added together, so AB plus BC is going to equal the entire segment. Okay, so that makes sense, right? Two things added together equals the whole thing, right? So we're just applying it now more geometrically than we have before. All right, so let's go ahead and do an example with our segment addition postulate. All right, so over here on the left, we have a nice segment with lots of points on it. And then this is the information that we're going to start with. So let's talk about midpoint. It's been a while, right? So let's remember that midpoint means that it's splitting that segment in half. So into two equal pieces, right? Right, so again, that is, so X is the midpoint of BZ. So that means from X to V and from X to Z are going to be equal. So let's write that down. So we know that VX is going to have to be equal to XZ, again, because X is the midpoint. All right, we're also given that V to Y is 16. We know that X to Y here is 2. And we know that, let me get another color here. And we know that from W to X is 9. All right, so we've marked all of our given pieces on here, so it's a little easier to see. So now we're going to be finding the length from W to Y. So that means that we're going to add up these two pieces here, right? From W to X is 9, from X to Y is 2. So that means from W to Y would be 11. All right, so again, we went from W to X. We know that's 9 from this. We know X to Y is 2. So we know that this entire piece here is 11. Okay. So in number 2 now, we are trying to find the W. So we're trying to find this piece here. So we know a lot of stuff in this range, right? So we know that from V to Y is 16. But then we also know that this piece here is 2, this piece here is 9. So to find this chunk, we can subtract what we know here from 16. Right? So we know that this is 11. So if we do 16 minus 11, that would give us that this piece here is 5. Right? So again, I took what I know, right? We know that this is 16. We can take 2 away and then 9 away, which leaves us with 5 for this piece here left of this whole 16. All right, number 3, we're looking for X to Z. So we know that XZ is equal to VX, right? Right, from that midpoint. We know that. So let's look at VX because we don't have enough info up here, right? So let's look at VX and see if we can use that to figure out that length of XZ. So from V to X, we have 5 and 9. So if we add 5 and 9, that gives us that Vx is equal to 14, which means that xz would also be equal to 14. Right, so let me draw that on here. So we know from here to here now is 14. Okay, so I'm going to skip number 4. Let's go ahead and jump ahead to number 5. We'll go back to number 4 in a minute, but it's going to be helpful for us for number 4, so from W to Z, right? If we have this chunk here from Y to Z. So let's go ahead and find YZ. So from point Y to point Z. So we know from Z to X is 14, and we know from Y to X is 2. So to find this piece, we're going to take our big 14 minus our smaller chunk here of 2, which would give us from Y to Z being 12. All right, so now that we know from Y to Z, right? Alright, so Y to Z, really, we could have done it by finding this piece here and adding up 9, 2, and 12. Or we can add 9 and 14 to get that. Either way works out. Right, so from W to Z, we're going to add 14 and 9 and get 23. Alright, and then finally we need to find from V to Z, so this whole length here. So I'm going to go from V to Y. I'm using my biggest piece here is 16, right? My 14 overlaps some, so let's jump to this next part we have. So it's 12. So 16 plus 12 is going to give us a segment length of 28. So it's just like piecing together a puzzle, right? It's just a puzzle with a line and numbers. Right, so you've got it helps a lot of people to kind of like draw it out like this using different colors so that you can see the individual pieces so you know when to add and subtract. Alright, so now we have the angle addition postulate, right? Very similar to the segment addition one, but now we're just talking about angles. So, if B is a point somewhere in the interior of this angle, then the measure of AOB, so the small angle here, plus the measure of BOC, this other small angle, equals the measure of the entire angle AOC. So again, you can add the two pieces up to get the whole thing. Alright, so let's again do some examples with this. Okay, so we know that the measure of STQ, so this angle here, is 78 degrees. We know that QTP, so this little piece here, is 31. And we know that STR, so this little angle, is congruent to QTP. So that means that this angle here is also 31 degrees. So, now we need to find the measure of STP. So, we are finding the measure of this, we're finding the measure of this big angle here. Right, so we know that these two pieces here add up to 78, and then this big one here is 31. So if we do 78 plus 31, we get 109. Alright, and we need to next find the measure of STR, which we already did, right? We know that that was congruent to QTP, so that one is 31 degrees. Next, we have to find RTQ, so this angle in the middle here, so R to T to Q, so this angle here in the middle. So we know that these two are 78, and this piece is 31, So we can subtract 78 from 31 to find this inside piece. So that will give us 47. Right, and then our TP, so we're going to add our 31 and 47, which we know from just subtracting is 78. Okay, so Ms. Jones is going to give you a practice sheet. I want you to try your best. If you guys need help, email me. I can set up on Zoom again, whatever you guys need, okay? But don't panic. Just try your best, and you guys have this.